Good morning, good afternoon, wherever you may be in your day. Thank you as always for choosing to make chemistry part of your day. I want to help a little bit with the math on the food content lab. So just remember, this is always a true statement. The change in heat for the system plus the change in heat for the surroundings will add to zero. Whatever one gains, the other loses, and vice versa. The system is what we're studying, the surroundings is the rest of the universe. So in the case of this lab, for part A, what we're studying is the candle that we're burning. And then the calorimeter is our setup to capture the heat, mainly the water with the thermometer in it, but it's also, the whole exchange of air and the room and all the other components that are in that, the beaker, your hand, the air above it. So that whole setup would be the calorimeter. So if we consider the candle a chemical reaction, as they describe on page 3, I want to make sure I have the right page. In page 3, you might notice underlined there is the delta H for this reaction. It's a little bit different than normal because it says kilojoules per gram. So to make it just energy or kilojoules, we have to multiply by grams, which is a mass. So it's a little bit different than what I have in class where I always have N here and it's moles. This is a little bit different, but it's amount. It's still amount times the delta H. So it's going to be M, the mass, times your change in heat. That's given to you in the lab, underlined, 43.3. And then we have the calorimeter. So calorimeter is always C delta T. We're going to measure the change in temperature in the lab. And then C is what we'll solve for in part A. This is what throws people for a loop sometimes. Then in part B, same math, except we're no longer doing a candle. We're now doing food. Oh, and the math's the same whether it's part B or part C. So now we're doing food, and the food we're still going to make M delta H, and this is C delta T, except now we use C over here from part A, and we're solving for delta H. And when you solve for that, you'll get kilojoules per gram, and you're going to need to convert that to kilocalories per gram. And remember, 1 kilocalorie is the same thing as a dietary calorie, or a calorie with a big C that you'd see on a label, and that's what we use for our comparison. And if 1 calorie is 4.184 joules, then we multiply both sides by 1,000, we still have a true mathematical relationship. So 1 kilocalorie is also 4.184 kilojoules. So pretty straightforward calculation here. I don't think the math's too bad once you get it laid out properly. So I did want to do a quick little video to help out with the math. And then as far as your conclusions go for the lab, I want you to summarize what you found per calorie per gram, and this is going to be from your serving, and then I want you to compare that to what you get on the bag. So you're going to have calories in the bag, and that's calories per serving size. Figure out how many grams are in a serving size, and take that ratio and compare the two numbers. See how your number compares to what's on the bag, and write up a little explanation for why your value might be different than what's on the bag. And that would be it for the conclusions and the math. So I'll do one more video to show you the setup, to go through the tricks of the trade with getting good data, but that should help a lot with the math.